V7 is released. We got a lot of quality of life updates, and for this I'll show you those real quick, and then we'll walk through a bit of a tutorial how to create this kind of fun particle world. Think of it like an intro to our TypeScript engine. First of all, when you right click, you notice that we updated our radial menu, so now you can create an entity from here. But now if you right click an entity, you also get the option to create another entity, or you can from here enter scripting, for example, or you could change to modify physics, or you could open up the light component menu and then start creating stuff from there. This will make it a lot easier to quickly make modifications in real time. Also, quite fun, if you go over to assets, you can now drag and drop scripts. So let's say I take this mirror logo script, I'm going to drag and drop it onto this entity, and boom, it's rotating right there, just like our mirror logo in the background. You can also do this with a material. For example, if I drag our land material that we're using onto this box, then that is actually rendering right there. Let me drag it onto the one with the light, for example, just so that you can see that, for example. So this makes things a lot easier. Previously, I had to do some drag drops or some select, and it just wasn't like that good of a UX. And so we want to improve that to make sure that you can quickly create games, make stuff in real time, and just have a good experience with it as a whole. So with that, let's dive into script. So click make a game over here on the left, and all these names in Mirror Engine right now are random. So we got Bramble Condor today, so this is going to be our V7 video. And apparently we just have a piece of land here, and it'll have a random material on it. So to get started though, first of all, we've updated the UI a bit, which I just covered in the updates. So we can just right click here and click the plus to create a new entity. You also notice quite nicely that since this is a entity component system, rendering the entity to the screen is actually just a component. So we can toggle that on and off here if we want to remove the cube, but we'll keep it on just for this reference while we script. Now I can right click, and I'm gonna go over here to script and then add a script. This is gonna go ahead and add that boilerplate script here. All this is doing, if you're new, we'll consider this kind of one of our earlier scripting tutorials with more advanced stuff to come. Initialize will be called whenever the game starts, but it won't be called whenever you update. So we do need to note that this swap method is called here each time that you actually update the script. Update runs every frame. DT is the delta times the time between each frame. And so that can be used to interpolate quite easily. And we aren't doing that just here. We're just rotating the entity one each frame. So let's go ahead and comment that out. And actually, I'll just delete that line for ease. And so what we're going to do first is on this side of initialization here, what do we want to do? Well, first thing first, we want to actually create some more entities. And so let's go ahead and do that. Just as a very quick example, I'm going to say const entity equals new entity. And there are some updates coming as far as imports and IntelliSense on our editor. It's still kind of base right now, but there's basic IntelliSense now to help you out. But this does need to be imported from Engine core. So we're just going to say entity equals new entity. What do we want to do? So an entity is just nothing by itself. So let's add a render component just like we have with our cube here. We'll say entity.addComponentRender render and what type. Again, I'm going to improve IntelliSense here. We'll just say type in this case is a sphere, for example. And let's hit save, and you'll see that nothing happened just yet. Just to be doubly sure, let's call this .initialize on swap. Still not seeing a sphere. You might wonder why. And that's because it's actually literally on the entity right now. Why you're not seeing a sphere, and that's because all we do is create an entity and add the component. But where's the component within, where's the entity within our hierarchy? It's not. So what we got to do is actually say, okay, this .entity, so this refers to this class here of this new entity that extends mirror script. And this is referring to the class and entity is actually a property on our mirror script here. And so we're going to say this entity.addChild, and that's going to ask what? Well, we're just adding that entity itself. This IntelliSense is out of date. This is an early alpha. We'll get that fixed for you. So then we'll say add child and hit save, and then it's going to reinitialize, create this entity and add as a child. You're wondering, wait, we just added the sphere. So where is the sphere? Well, if we go over here to our render component like we did earlier, we can turn that off and boom, hey, there's our sphere right there. It's actually just within the cube, and so we can't see it. So what should we do? Well, let's translate that so we can actually see it. So we'll do entity.translate. In Mirror Engine, Y is up. Just makes sense. I love it. I know there's a big debate about this. So hit save, translate, and boom. Hey, look at that. Now we added the sphere right above this entity here. And so whenever we save the script, again, swap will be called, this .initialize will be called. To demonstrate, let's say we actually, let's do a cone instead. So I'll just say cone and hit save there. And now we have a cone right there, or that could have been a box, for example, and now there's a box up there. So you're probably wondering, well, wait a sec, that looked like it was overlapping. So yeah, if we go back over to render here and we turn this off, you'll notice that we still have this sphere down here. And you might be wondering, well, what the heck? What just happened there? Reason being is because this script is rerunning each time. And so whenever we add a new component, this entity actually has a few entities. So I'm going to give you one more quick code snippet here. And again, this is something that will be improved in the future with Mirror Engine. Hopefully we'll add an easy way to just do this yourself, or excuse me, automate it so you don't need to. But we're going to call this entity .children.forEach. So if the entity has children, this question mark is checking in case the property doesn't exist. TypeScript safety there, which we'll dive in more in the future. Then for each entity, let's destroy the entity, e.destroy. And so I'll hit save. And so what that's going to do is any entities that were under it are going to be removed. And so this is still existing quite nicely here because it still reran this .initialize, so it's adding that child here. So now if I do save, looks like that did not actually destroy. And so I'm gonna run that again. This is definitely a bug. So I do want to be transparent about our bugs that we do have, and so this will get fixed. And I just want to let you know that if you're following along in V7, this is a bug that you may need to work around doing this. So I'm just gonna leave this here, transparency, and just note that this will get fixed. Yay. And it's just a white cube right now, so let's make it cooler. Let's instead do a material. And so this time, instead of just creating an entity within this scope here, these two curly braces are block scope. So that means this const here just exists within these curly braces here. I'm going to declare a new class property, and we're going to name this material. And that's just going to be as is. It's giving us this red squiggly because it's saying, hey, this implicitly has an any type. You should type it. And so that's a setting that is from the TypeScript config. We'll allow you to toggle this in the future if you want, but it's just letting you know, hey, this doesn't have a type. Any TypeScript, though, is valid JavaScript. So don't fret. You can still use this as that here. So we'll just leave that as is. Don't really care. It's TypeScript is kind of like a nice buffet of if you want to use this, then great. If you don't, then you don't have to. So life is good. All right, so what we're going to do now is then say this material. So this is referencing the class property. And we are going to say a new standard material. This is on our docs as well. So we need to bring this in as an import. Also another bug, again, alpha. We have a lot that is getting fixed quickly and improved, but we do need to import this here, and it's going to complain. This is the bug that doesn't export it just yet. Again, will get fixed, but I wanted to give you some walkthrough on this coding tutorial here. So we create this new material. It doesn't really do anything just yet. It's just an empty material. So we're going to say this material.diffuse. Diffuse is basically the color. If you're new to game dev, a fancy way of quite literally how the light diffuses over the way it's rendered on the screen. And so we're going to say the diffuse is a color. So we'll do a new color here. We'll just say we're going to use a blue since we're with Mirage, which is pretty blue. New color 001. We're also going to update the import up top and say import this color. And then so we set that diffuse to that color. And now we need to actually say, okay, we want to take this material and add it to the entity. So technically the entity's render component. So then on this add component, there's another argument here for material. We'll say this material right here. And then I'll hit save, and you notice, boom, now we got our blue here. And just to be safe though, we do want to call this material update. I'm gonna go ahead and leave that here for any real-time updates because Mirage does try to be as optimized as possible so it doesn't necessarily run all the updates right away because we'll be making some changes to this material. So the diffuse is now blue, and because we have something rendering here, I'm going to actually go back to our render component and turn this off just so we have our floating box right here so we know what we're just creating by script. So if I go over back here, let's make this even cooler. Say this material. We can do a lot of things here. Maybe add some gloss and hit save, and don't really notice much there just with the gloss itself, but let's also add this material.metalness equals 1, and actually I want to say put down gloss to 0.3, and let's see, no real changes just yet. That's all right. We also need to know that this material.use metalness. Oops, that just jumped up there. .use metalness equals true for the workflow. There we go. Now we're actually seeing how this plays here, and what you can also play with. If we go over to our entity hierarchy, each game you create out of the box does have some lights. So I can grab this light right here and bring that in. Then you start to notice that the way that this light reflects off of the cube will start to look different. So lots of stuff we can play with there. And a lot more mesh tools, a lot more material tools, a lot more things we can do in the future. Because a key part of this is that Mirage is truly an all-in-one game engine, and so we want you to be able to really truly build everything here, whether that's creating materials, whether that's working with lights, for example, working with scripting, working with meshes, Gaussian splats, whatever you'd like. So we've got this here. Let's go back over to our script, and actually, I need to select my new entity here. I'm going to name this base, just because it's our base entity we're working with. And let's do another thing. Let's take this color and actually declare that as a class property. So we'll say this dot color. We need to go up here and declare this new color as a property, and we'll just paste that back in. And so that's easy because the reason being is I want to actually reference this as I want to add some emissive. So we'll say this dot material.emissive, and emissive is also a color. So we'll say it's this dot color, and then I'll hit save there. Boom! Hey, now we are glowing a bit, and so that's looking kind of fun, especially if hey, that's looking kind of fun. So then you could see that. Even in the dark, that is emissive. That is glowing right there. So we can have some fun with this. So I'm going to move that entity back real quick, pull that over here, and then we'll continue to build. So opening up that script again, And all we did essentially was just create this new material, add some cool properties to it, call this material.update, then add it to the entity. Life is good. And one other thing to know is that this emissive is pretty strong. So what we can also do is call this .material.emissive intensity here. So I'm going to leave my emissive intensity actually at 0.5. Oh, Klaus is at 0.3. And so next thing though is like, you might be thinking, well, this is emissive glow, but it's not really glowing. It's just like the light is quite literally showing through the dark. You are totally right. So let's change that. Let's actually create a way to change the rendering of how the camera works. And so this is going to be a kludge script for sure, but we'll provide some shortcuts and clear ways to do this in the future with more intelligence. Just want to give you an update on what we are building so far and how you can build this yourself within the Mirror Engine Alpha. All right, so what we're going to do here is we're going to find our camera. So this .app.root. So app is the application, the base game application, and every game application has a root entity. So you call this .app.root, and we're going to say .find components. So that's going to find components. These are all in our docs too. But for the sake of this tutorial, we'll just give you a quick snippet to do this. We'll filter through finding which camera entity is enabled. So what I want to do is find if cameras.length is equal to 1, to make sure that we do find a camera, then this camera is I'm just going to assume it's the first. Probably not the best assumption, actually, but we'll use it for this tutorial because it would be better proper to loop through each camera and adjust these, but it's important because there actually is a difference between build mode and play mode, which are two different cameras that we have here. This is just going to find our build mode camera, actually, because it's the first one that was created in the scene. So then we're going to create something new. This is called camera frame. And so we can say new camera frame right here, and the jargon stakes in. This will be in the docs as well as the setup and camera. And then what we can do then is actually modify how the camera is rendered. So we can call camera frame.rendering.samples. We want to take 2 samples, and here's where it starts to get fun. We can say camera frame.bloom.intensity equals 2, and then camera frame.bloom.blur level equals 1, and then finally we'll call it. So just some basic camera frame settings. Again, this will be in our docs if you're confused. And whoop, that did not work. And so, hey, look at this. This is our new error setup that we have here. It's going to tell you which entity is on. It's on our base entity. Error is cameras is not defined. And cameras was right here. And that's totally correct because I said constant camera. I need to say constant cameras. Whoop, hit save. And then camera frame is still not defined. And that's because I didn't actually import this. So our message is working nicely. That was updated by yours truly. So I'm going to make sure we import the camera component here. And also camera. And if you're new to TypeScript, this as camera component is actually just compile time type help. Really code time. It's not actually running when it's compiled. It's just for type safety and type hints. So I'll hit save and boom. Hey, look at that. Looking good. Now our cube is glowing a bit. We also got some nice blur. Our cameras look pretty good here. We're going to do some fun stuff. I like this a lot. So the intensity is 2. For example, if we did 1, it looks like that. If we did 10, then we get that. We can do a lot of cool stuff here with just modifying the camera frame, or it could be, hey, maybe we just want to add a lot of blur, and then we get it like a real blurry, a lot of effects here. We can do some fun stuff. We could have a lot of fun with this. So please play around, enjoy, have some fun. So this is working nicely here. I'll just do blur level at 1, but I do like some of the intensity of this blur here. Maybe at 1.5. We'll play with it a bit. So far, we only have 1 entity, so let's make this a lot more fun. Just doing 1 entity isn't very cool, so let's do a lot. So let's move this const entity equals new entity down here, and so this is just our material section. Let's come right there, and instead, so what we're going to do, I'm just going to cut this real quick, and for loops, we'll say let I equals 0, while I is less than, we'll say 500 for the number of entities, whatever we want to create here. Then increment I each time that this loops through. And so I'll repaste this here. So now this is going to actually run 500 times. It's going to create a lot of entities here. So I'll hit save, and that will just go ahead and run. They're all in the same position though, so that's why you may not have noticed any change here. Just because this is all at the same position. So in our update method, which is called every frame, we're going to say this entity dot children, and so that's an array of any child entities it has. Dot for each, and what this will do is allow us to pass in. We first get the entity, then we get the index it's on. This is called an arrow function in TypeScript, if you're new to it, TypeScript/JavaScript. And so it's going to loop over every child that this entity has. Now, I've already done some of this math in the background, so I'll just give you the snippet real quick, and then you can play with it as you wish there. We'll talk about it. Pasted this in real quick. And so what this is going to do is loop over every entity. And so we have a radius, and this will be the radius from the center. The speed is 500 is actually the same 500 instances that I'm using for reference. And you can also just, instead, if you wish, create more entities. We can play with it a bit. And what we're going to do is set the entity's local position. So the radius times the math.sine, the math.cosine for the y and z axes here. And we're going to multiply that by the index it's on, this.time times speed. This.time, this is a new variable that I added that's just time equals 0, technically a class property. And what we'll do each frame is actually increment that as well. So we need to add this here. So we'll say this dot time plus equals dt. And so that's shorthand for the set time equals the set time plus the delta time. More fun and more beautiful. So what I'm going to do here is actually, let's turn off the lights. And so I have this first light entity here. I'm going to delete that. Just hit backspace. I have this second light. Going to delete that. And our third light here, that was just the spotlight. Boom. Turn off the lights, and let's zoom out a bit here because our land is going to be in the way when this starts to look really cool. So I'll just move this up here. Raise my camera a bit with Q. And so now what we'll do is we added all these entities. Now with this for each loop, let's do some fun stuff. So first of all, we used entity.translate earlier, and so for each entity in this case, we want to set the entity's local position. So we'll do set local position right here, and this is going to be on XYZ. And so in this case, just for kicks, let's create a radius real quick. So in this case, our radius equals, to start with 10, and then we'll just play with it here. So what happens if we set the entity's radius all around to 10? Well, it's just going to set it in one position. No real variety there. And so what I want to do instead is actually, well, modify that based on the, let's say, the index. We can add time, we can add speed, a lot of cool stuff we can do here. What's really good to use here is a sine wave, because that automatically interpolates, and that can kind of act as like going in between, well, a wave, and then we can start to make pretty stuff. So we'll say radius math.sine. Let's use the sine of I, the index here. So this is going to loop through, give us index 0 all the way through our 500 entities that we have. And so technically 499, but let's just say math.sine for all these, and then last as well, math.sine. We can use cosine as another example. Let's see what happens. Hit save. All right, we just got a line there. Well, that makes sense though, because it's just all based on this, just the sign, and based on the index here, so we can start to have some fun. So what if, for example, I encourage you to just play with this, have some fun. We hit, we use cosine for the y-axis. Now we have a good looking circle here. Maybe if we had cosine for z as well, then we're just gonna get another circle there. So lots of stuff that we can start to play with. For those that, even though these indexes are different for each, well, entity, so index, the first one is index 0, second one is index 1, and so forth, it's not actually going to change each frame. So that's where delta time comes in nicely that we can use. And because delta time is going to be, it's going to be like a very small number. Let's actually go up top and let's declare a new variable, a new class property called time. And so let's go up top and let's actually create a new class property called time. And this is just time equals 0. And so what we're going to do is, because this dt is the difference in each frame's time, we're going to say this dot time plus equals dt. If you're new to TypeScript or just coding, this is really saying set time equals set time plus dt. You can do whatever you want. We'll choose shorthand for now, so it's a bit cleaner. Set time plus equals dt. So this set time is going to be the total time that this script has been running. And so what that means is we could quite nicely use that in our calculations of where we're setting the local position. So we'll do I times this dot time for the x-axis. Let's just hit save and see what happens there. Oh, we got craziness. This is getting fun. It's not time for y-axis. All right, we got something pretty crazy looking there, and this thing is moving really fast. You might need to modify the speed. And then if I hit the, excuse me, that was a typo there. Then if I hit this at time here on the z-axis, then we're getting this pretty crazily rotating slice. But hey, this is fun. This is some cool stuff that we can play around with and just keep on working towards to polish our script. So these are flying, moving really fast. Let's modify this a bit. What we could even do is say, if we want to alter these by the axis a little bit, say 1.2 for Z, then we start to get something like that. Or maybe let's do let's do 1.1 for the y-axis. Oops, that's a typo there. Then we start to get that. There's a lot of cool stuff that we can do here. Let's even say, hey, maybe a, I don't know, 0.9 for the x-axis. And woo, this is beautiful. Math is just a lot of fun that we can start to play with here. So going back down, let's say in this case, I want to slow this down. And so if I assume each of these have a base speed of 1, and just because all these are 1 speed by default, if we create a new speed variable, this speed is going very fast for even just what it is. So if we want to reduce that, we could say, so this is looping through 0 to 499, then we could just essentially normalize it, if that's the right word here, from 0 to 499 based on how many, based on what the index is. So instead we could say the speed is the index, so think it high if that was 499, divide that by how many instances we're using, in this case 500. Because this is going to be a speed less than 1, that's going to reduce it for each of these. Just do it for the y-axis there, and oops, I had a bug up top. That gets still pretty crazy, and that's because our z-axis is still very fast. But this is still going nuts here. Let's instead just add 2 zeros and see what happens. Oh, beautiful. Hey, I'm digging this. All right, so there we go. This is just kind of drawing this beautiful thing we got here. Let's add another 0 and see where this goes. All right, now that's a little bit more tolerable. It's still kind of too slow. I'm just really playing with numbers here. Let's use that too. Yeah, there we go. All right, cool. Hey, having some fun here. All right, so this is just drawing this here from our kind of just random stuff that we're playing with to create this good-looking mathematical particle field with entities here. Not even truly particles. Those are coming as well. So one thing that would be fun here is to vary the radius a bit. So, because it's just a constant radius, all these have a radius of 10. But what if we say, let's add the index it is. So that means we should get something that's a bit more spread out here. Wow, that just really changed things. I'm using my mouse wheel to scroll out pretty hard here. I hope you can see this on the video, but this is just like getting galaxy level. Probably a bit too big. So let's maybe divide that just by 500 there. All right, zoom in back in real quick. And while we're at it, you notice this little particle dude down here, and that's our current player one placeholder. Quick to keep in mind, if you are coming in hot, new to Mirror Engine, this is actually running at real time. So if I press B right here, I'm actually running around as my character, like this little Ghostbusters dude. Look up and boom, there's a beautiful particle field that we got right here. I can press B again, and you saw this was moving down here. That's my player in play mode. This is all real time. It's a completely different way to make games, because if I go back over to our base entity, let's say I drag this down, so it's kind of like in the world that I'm creating right here. Then I will put that there, and then I press B, and boom, I'm like in this particle field. Also, you'll notice that there's no bloom. That's just because we're modifying the build mode camera at first, actually. Instead of doing that, let's actually just say use our loop again, cameras for each, and this is camera. Pulling that in there. Our autocomplete needs to be improved here. We will get that done. So let's move this back up here, and then I can remove that, and then so I'll just say, all right, now we're looping through every camera. I want every camera to have this bloom here. So I go back to build mode, and now this is actually play mode. So now I'm running around as my Ghostbusters dude, and this is actually working well here with the bloom effect. And it, with how fast this is moving, I'm gonna reduce this again. If you're Bob Ross, you're painting something, just kind of play with it. Or if you're a designer, you know, you're in Figma, just play with it, just have some fun, see what we can do here. But in this case, I think it's fun to add some more intensity. So we'll do a 4.5. Why not 10? Let's have some more fun. Whoop. All right, that's looking kind of good. Even to the point where it's just like getting really blurry with how much bloom there is. So that's kind of fun there, but our script's still running too slow. So, or excuse me, this particle field. All right, cool. Now we're having some fun playing around with this. So a lot of stuff we can do here. And ooh, even my Ghostbusters dude is looking pretty glowy because of the bloom that we just added here. This is a lot of fun. And keep in mind, this is all multiplayer. So do this tutorial with a friend, and then you can be building this world together in real time. So one small thing that'd be fun to do here. So currently our radius, that's just taking, essentially incrementing by 1 for each index it's at. So if it's at index 20, then it adds 20. If it's at index 30, it adds 30. But let's make that more dramatic based on what index it is. So we can say I times maybe 15 in this case. Ooh, there we go. Now we can zoom out a bit more. And earlier our world was pretty crazy with what we were doing. Oh, it's kind of trippy. So that's playing around there. We can then do 25. I'm gonna actually increase the speed a little bit by dividing that by lower amount. Ooh, there we go. All right, now we're hot. We're playing here. Whoop. All right, cool. I like this a lot more. All right, this is fun. We are playing around here. We created this cool particle field. All right, boom, good progress. All right, next up though, it's all blue. Let's make it also based on the delta time, the time that we're incrementing. We can use variables like that to interpolate. So what we'll do in this case is we're gonna create a new color, and we're gonna break this out pretty hard. There's other, probably more efficient ways. What we'll do here is then take R equals T, and just time. New color B equals time, and we'll normalize all that. New color B equals time. But this will not be normalized, of course, because it's just a raw incrementing number. So actually what I'm going to do is say math.cosine of this time here, and then just paste that in this case, and I'm just raw copying these because we'll vary it for each. So this will normalize it as a scale between 0 and 1, and then we can modify it a bit for each. I think I might have a bug in my math here. I'll double check that in a sec. But what we'll do then is let's go ahead and say this dot material. So what we could do, a couple of things. We could just modify the material directly. In this case, what we want to do actually is modify the mesh instances. And so what we're going to say is for constant mesh instance, and more on this to come. This is maybe a little not as intuitive to have a mesh instance versus a render component. Don't worry about it just yet. We'll cover this more in depth on a future tutorial. And we also got to polish some engine stuff for it as well. And so we just want to get a reference to the material on the mesh instance. So we do mesh instance.material here. I'm going to do a question mark for type safety, and this will also be with editor hints in the future. JavaScript is by reference, and so it's not copying the value here. It's actually just copying a reference to this dot material. So this is just for simplicity here. And then we're going to say this dot material dot diffuse equals this dot material dot diffuse. And then we also want to update emissive, so we'll say material dot emissive equals this dot material dot emissive. And of course, we haven't changed these yet. We're just saying, hey, we want to update these every frame. And then I'll just last add material dot update, still referencing the material on that mesh instance here. Then I'll hit save. And so, of course, you won't notice any difference yet. This is just going to rerun our... Ooh, I think I might have a bug here. So that just stopped. One sec. The bug was because I moved outside of my for each loop. So just copy this, move this up. That was just a shortkey of Option arrow. All right, cool. We're back. All right, so all this did was just kind of reassign the same stuff that we already know based on the stop material, but we didn't actually update the stop material. And so you probably already guessed, or maybe you did this yourself. What we want to just do now is say the stop material dot r, which is the r property, equals new color r. Again, there's probably better syntactical ways to do this. I'm just trying to be very explicit for the sake of this tutorial. So say new color g, and then this dot material dot b equals new color b. All right, so that didn't work yet, and let's figure out why. So this dot time, this actually needs to be better fixed for normalization. So why don't we say this dot time, it's the math dot cosine plus 1, and then we're gonna wrap that here, and then we'll just do the same for the others real quick. Oh, sorry, y'all. I completely goofed. I was modifying this dot material when really it needs to be this dot color. Sorry. We all make mistakes, and I'd rather just show you the mistakes I made than try to pretend I didn't do it. So this dot color dot g, this dot color dot r dot b, and obviously our type sense missed that too, and so we'll fix that in the future. So we'll modify this dot color dot r equals new color r, g, b. So we're just modifying those three properties. This dot color was the color that we declared up here, and that's also what this material dot diffuse and this dot material dot emissive is rendering. These are color properties, and then so we will assign those new color properties to the material. And so this is pretty obvious here. So what we now need to do, so we updated the color, and now we need to actually tell the material, hey, just for sake, we're going to reassign this equals this dot colors. This is this dot material dot fuse equals this dot color, and this dot material dot emissive, because the exact diffuse is different than the emissive, which is actually the glow, more or less. Of course, accompanied with our bloom. Ooh, baby. All right, look at that. Now we are hot. We are playing around, and we got this good looking color change here that we can start to play with and have some fun. All right, and so what we did here, so RGB, these are all, let's use this dot time dot times 0, and I'm going to, in this case, say this dot time, it's probably not the best, let's actually just add 0. So this dot time plus, that can stay as is, but I'm just showing this for reference. So this dot time plus 2, this dot time. All right, so I was playing with this a bit, and here's what I came up with as a better solution. If we want to, say, make this more like a progression through a rainbow of colors, what we'll do here is, instead of saying this dot time times 0, we'll actually multiply it by 2, and then just for reference, it's adding 0, but I'll say this dot time times 2, in this case plus adding 2, then this dot time times 2, in this case plus 4, then I'll hit save, and ooh, look at that. All right, so that kept us more within color spectrum, because it was hitting a lot of white, then going back, where I'd rather just keep it interpolating through non-whites, so we can get a lot of saturation, a lot of variety here. Although it will get close to white, but not exactly at it. All right, we made a lot of progress. So last but definitely not least, you might be wondering, well, how is this different than any other game engine where I could have done this? First of all, this is all time. This is actually multiplayer here. And so if we go over to the left and click invite, then I'm just going to invite a friend here. Up a new browser and then pass that in. And so I just logged in here as this other user, and woot woot, here we are actually running this in multiplayer in real time. This is actually going to be slightly out of sync, and that's because the script started at a different time, so thus you'll notice that the colors aren't the exact same, but we'll make sure that's synced. This is still something that we are constantly improving in the engine. And so that's part of the joys of real-time development, together with friends, kind of like Inception. That's our goal. It's a ton of fun. It's a totally different experience to be building a world together in real time with your friends. So be sure to sign up for our alpha. Be sure to subscribe on YouTube. There's a lot of good stuff that we have coming. We'd love for you to join, and hope to see you in the mirror. Cheers.